This is a recording for the Unit 7 pre-lab on the electric circuit experiments. So obviously question 1 is that you, the student, will attend the lab intensive. Then this question here is Ohm's law, DC circuits, the objectives. So make sure to look at the lab manual. Again, that's what these pre-labs are about. You need to have looked at the lab manual so you're prepared for the lab intensive. These 3 are the objectives that you will find there. This question here should be in the correct sequence. When resistors are connected in series, their resistances are simply added. In a series circuit, the battery's voltage is shared among the resistors, whose individual voltage is also simply added up to the total voltage. In a series circuit, the electric current is the same flowing through all resistors. Then, for parallel circuits, when resistors are connected in parallel, the reciprocals of the resistances are added. In a parallel circuit, the battery's voltage is the same across each resistor, and in a parallel circuit, the electric current is split up among the resistors. Okay, this question here, these are the procedures for the same lab. To a certain extent, they are in the correct order. How are resistances in series added? Simply add them. Are resistors in parallel added? What do you need to do after that? Add their inverse reciprocals, invert the result, because the equivalent resistance is also a reciprocal. When measuring resistance, the battery has to be disconnected. When measuring resistance, the ohms meter leads must be in contact both sides of the resistor or whatever component is being measured. When measuring resistance, the switch dial on the ohm meter must be pointing to most applicable resistance, usually ohms or kilo ohms. When measuring voltage, the battery has to be connected in a closed circuit. You can see these are all in sequence. Now, this next one here, there's a restatement. So when measuring voltage, the voltmeter leads must be in contact with both sides of the resistor or components that is being measured. So when measuring voltage, of course, the statement right before that says that you have to have the battery turned on. Otherwise, you're not going to read any voltages on any components. When measuring voltage, the switch dial on the voltmeter must be pointing to the most applicable voltage, usually V on the top left. And then when measuring electric current, the battery has to be, again, it's a restatement, connected in a closed circuit. And then the last ones here should be in sequence again. When measuring electric current, the circuit has to be interrupted at the place where the current is being measured, because that's where you insert the multimeter, which is, this case, is the ammeter. When measuring electric current, the ammeter leads must be placed into that gap. That's what I just said. And then you can look at the other statements here, which again should be in the correct order, but of course, make sure that you look at the lab manual itself. Okay, this question here, they should be in the correct order. Procedures and data analysis. How many color bands does each resistor have? Likely 4, perhaps 5. I'm actually trying to get rid of these here, but there might still be some of them surviving. What do you have to do with the colors? Each color needs to be assigned a particular digit from 0 to 9. That's part of the lab. You will figure out what we mean by that. What is the quickest way to measure the resistance of a single resistor? With your fingers, clamp the resistor's leads to the ohm meter's leads. So that's one way. Or you put them into the spring sprockets and measure it then. Likely that also apply it just for color bands, and then the third color band, which may not apply, I'll just leave it blank, and so on. Again, these should be in the correct order. All right, still the same lab. There's an example posted in there. Notice that you will find these numbers in the example. And then there are a few down here. These statements may be correct. They're just not posted as the example in the lab manual. The other lab is the Capacitance Lab. These are the objectives, these 2. Then look at the theory part. And these should be in the correct order. So a capacitor connected to a battery will charge very rapidly because the current is very large. A resistor connected with capacitor in series limits the current, which extends the time and makes measurements actually possible. That's why you will be using the largest resistor that you will find in the supplied materials. Graphing the capacitor's voltage versus time shows that during charging the capacitor's voltage increases rather quickly. Then the voltage gets smaller until that capacitance voltage approaches the battery's voltage. And again, read through these yourself, and they should be in the correct order. The procedures, which resistor should you use? I just mentioned that, the largest possible ones, the largest possible one that we supply. How do you place the capacitors relative to the battery? How do you place the capacitors with the resistor in the circuit? So the side with the negative sign should be facing the battery, the negative pole of the battery, and the resistor must always be in series with the capacitors. Which physical quantity should you measure directly? Just once with the multimeter, the resistor's resistance. Which physical should you measure directly? Which physical quantity should you not measure directly? I'm sorry, the capacitance, that's what the experiment is about, because there has to be a roundabout way. Okay, notice that A, B, C, D here, this will be out of order now. While charging or discharging the capacitor, what physical quantity are you measuring? You're measuring the voltage. And how do you measure it? Place the leads and so on. You can read through this one here. And then what should the R squared value be? On the Excel graph, close to 0.999. During the lab, we will explain what that R squared value, the regression value, actually means. And again, you have the other answers here. Again, make sure to look at the lab menu. Okay, when you look at the example for the capacitance, you will find these statements, and I believe it's all of them that apply. So that's the recording for the pre-lab 7 for the electric circuit labs.